Okay, thank you. Hello. Welcome to my session, Security as Code, a DevSecOps approach. My name is Joseph, and I think the highlights of my security career so far, it's a zero-day vulnerability in a top 10 cryptocurrency project. I showed them how I could stop transactions blindly that they were legitimate. So I love innovations, but I also want to see security in those. And I'm working with a team that is trying to secure the open source software, the software that we all depend on. And we do this in different ways. One of those is to find zero-day vulnerabilities in open source. And we found these numbers so far, 356 from March 2020. So it's one every 3 days. And these vulnerabilities are in software that you know and you use, or they are in your supply chain. The other ways we help to secure is by giving workshops, by helping with education and awareness. And lately we came up with this initiative, which is to give for free, always, our consulting to open source projects. We call it office hours. So they come to us and we form a team of 3-4 people based on the programming language they use, based on the problems they want to discuss with us, and we discuss what they want to know about security. So far, we helped 6 open source projects, and I actually wrote a blog 2 weeks ago about it that you can find in the GitHub security blog, what we learned about it. So if I summarize quickly, these projects suffer from the same problems. Sometimes it's around design, sometimes it's about the way they do things, but there are patterns there that we can all know and use. Today I'm going to speak about something different. I'm here to introduce you to security as code, which is an approach we implemented in the last year. I want to tell you a story. So this is a story about a company called NASA, and it's a real story actually. So this story has a part that happened 10 years ago and also has a part that happened 1 year ago. In the 10 years ago part, you see a snippet of code in the screen, which is code very similar to the one in production. So 10 years ago, NASA engineers wanted to go to Mars. And they wanted to do this by a mission where a little robot would land in the surface of Mars and do some sensoring, gathering data, etc. And this snippet of code was responsible to open the parachute. But at the very last moment in production, someone from the team was like, do you want to check for the last time the code? If it's okay, let's do a little code review. Does anyone see a problem with this snippet? So there's a problem in line, I wouldn't say in line 2. So let's say that in line 7, there's an array of 3 elements being introduced, but then the loop in line 2 goes over 12 elements. So you can have random behavior from index 4, 5, until 12. This could cause the rover to crash, but what they did was something that it was smart. They work for NASA. So they did this, they wrote a query in the language I'm going to introduce today, and they found 30 other similar problems because they understood that if we have this style in here, maybe we have it somewhere else in the code as well. So they wrote this generic query and they came up with 30 other instances, variants of this problem. 1 year ago though, by the way, they fixed it, all okay. And 1 year ago, they started doing another mission to Mars, this time with a robot called Ingenuity, not Curiosity, like the previous rover, and they used security as code in the way I'm going to show you today. So the same things we do today, they do at NASA. The way that we work and the way that NASA works is this. So my team, with the 356 vulnerabilities, is writing queries in this language that is called CodeQL. Many of those queries found zero-day vulnerabilities. Then we have the community, companies like NASA, other companies in the world, that they do the same thing like we do internally. and they give us that knowledge. So we share that knowledge with the rest of the people. And finally, we have our hunters, which are people that are receiving money, bounties, to find issues in the way we do security. So this methodology is called security as code, and we are inspired about it from the lessons that we learned from DevOps and also from quality assurance over the years. What we learned was that security doesn't work well when it's broken into silos, when you have developers doing one thing, when you have security doing one thing, etc. And all I say is applicable to monitoring because it always works in a very similar way. So I might inspire someone today. So what works is a developer-first approach. When you have the developers doing what they do best, which is building functionality, and security is doing their thing in a way that is friendly to developers. So we define security as code as the methodology of codifying security decisions that are then shared with other teams. So if security people write code, developers can read that same code. So you all read the same thing. You are all aligned. You are all in the same page. Therefore, you are talking about the same thing. And if developers read that and understand that, then they can see what's the problem, and there's no need to decrease the speed of things. So this way, security becomes more like a background operation, monitoring one, that it's only like evasive when something wrong is there. And I'm going to show you security as code today implemented by CodeQL, which is totally free for open source. And it's a language that is querying code as if it was data by describing what to find, not how to find it. For example, from these humans in the room, give me the one standing in black shirt because he's malicious. So you just describe that, it's going to pick me up, and I'm the bad person I go out. It's a project-oriented language to help with types, etc. Similar to SQL, but it's more expressive. And it's developed in the past, in total 13 years now, over the lessons learned that we had. So it's for query code. This means that you can query because you want to learn, to search something, you want to learn about your code base, but at the same time, it's used for software security. And it's supporting languages like Python, C, Java, Go, C++, JavaScript, Ruby, and Rust with Kotlin coming. Therefore, you can pick up vulnerabilities in those languages. Behind the scenes, what we do is that we build an abstract syntax tree for everything that exists in the code. So an abstract syntax tree is a relational database. So this way, if we have a relational database, we can do advanced search and establish relations between the things. It's a SAST tool, not a DAST tool. So it's only doing static analysis, not dynamic analysis. It doesn't run the code. And since many people in here are maintainers of projects, how many, by the way, are maintaining actively projects that are free for open source? Okay, thank you. But in the overall conference, you are way more. So you have passive users and also you have active users. What I consider a passive user, it's someone who has CodeQL as a form of code scanning in the CI/CD pipeline. For example, I just push my code, and then an automatic action is scanning that code and finding out problems. So if NASA finds a problem with something, then this check, it also has this NASA check to find it. If my team finds something, then you benefited from this check as well. This passive user only takes 2 clicks, 3 clicks. It's security, code scanning, enable code scanning. That's it. Now, today, I'm going to show you the active user. Because with some rules, you can be the one writing the rules for the private code base you have, etc. And I'm going to show this through a SQL or SQL injection. Who is familiar with the vulnerability? So you are confident that you can recognize it in code. Okay, a few. So I will speak about it. So as per the meme, it occurs when you have basically insufficient input checks. Someone here in a school expected that someone in the internet would be really kind and only put Robert. In reality, they could add more stuff and dropping students, creating an admin account for themselves, steal data like credit card details, etc. So in the previous example, you have SQL code looking like this, insert into students a name. What is in purple is the input. So the developer expected Clio or whatever name to be the name inserted, but in reality, you can do whatever you like. So let's now wear our security hats. In reality, we have a source of an issue, a source of a vulnerability, which is this part of the code. And we also have a sink, where is the place that what is malicious is being executed. So the sink here is where the query is actually being passed. The vulnerability only occurs if you have a flow from sources to sinks. Otherwise, you have an unrealized error. It's not a problem, it's a false positive. And today, I'm going to show you CodeQL in action by writing some code together. So I want you to live from here with the basics in mind. And also because the internet is not so reliable, I can't really show how you can enable it. So I'm happy to show you outside. Come and talk to me. If I turn into my VS Code here, I'm going to use a code base that is vulnerable, is intentionally vulnerable, and it's from OWASP. So it's called Security Shepherd. I want you to think about a normal Android app that you open this app in your phone and it has a username and a password, so you do authentication with it. So basically, here it's asking for your username and the password, but as you can see, there's no like sanitization happening. But in reality, I want to make sure that there's an injection there. I want to write some rules to monitor for SQL injection vulnerabilities in my code base automatically. So to do this, I need to write a few lines of code. And let's write this together today. So like we said here, the source of the problem is where the input gets into the code base. So if I write this from scratch with CodeQL, this can be like the following. First of all, I want to import Java because the code of Android is in Java. And then I told you it looks like SQL. So I have a from, where, and select statement, which takes this form. So you give a type, you give a variable, you give some condition, and you return something. For example, from all the humans in this room, from human H, the condition is the shirt and me standing. So I use the and the or because there are also logical connections. We are in an abstract syntax tree. Return this H, this human. So if we write this with the code we have, it can be from the type methods, which is all like the methods in the program, so that we come up with those that are doing user input. Let's just do select all the methods. So this is going to give me back all the methods in the program. It's not so useful because some of them accept user input, some of them not. I want to put another condition in, which is just give me those that accept user input. So I'm using like auto-completion here to benefit from that. And I'm only interested in this method called getText. That is the source of the vulnerability. Many people are like telling me, oh man, you know, this looks like grep. It's like command find. Well, it's not, because you are gonna see in a few moments that it's way more powerful through taint tracking and data flow. You can monitor a variable wherever it is. So if we do this, right now, I'm gonna get my hands into all the ways, all the areas that the getText method occurs in the program. I have 3 of them. I don't know if they are vulnerable or not. I just know that user input, either malicious or not malicious, is getting in 3 places in my program. I now want to check for sinks, which are places in the program that this malicious code is going to be executed. If it's not executed, I have a false positive. So this is the methodology we followed before. From all the methods, we filtered and we arrive in getText. Now, the sync is the raw query method, but specifically is the first argument. Because if you are like putting rules for both of them, you are going to come up with loads of results, taking your time and your effort, and maybe you are going to miss the actual problem. So the actual sync is the first argument of the raw query method. So I'm going to use the AND operator here. So far, the query is getting the raw query method to get to the specific argument, which is the very first one in index 0. So if I run this, I'm going to come up with the... I need to introduce another variable in here, so with the type expression, and I run this, and I come up with the raw query method executions in the program. I don't know which of them are vulnerable. So in reality, what is really helpful is this code here. This is a template. I didn't write this code. This code was given to me. I don't know who wrote it, maybe someone from the hunters. Basically, it's coming from the community, okay? This code only has two placeholders, one for the source and one for the sink, so that it picks data flow from a source to a sink. And if there exists data flow, we know we have an SQL injection. So I'm gonna just copy and paste what we wrote. And also it's a good opportunity to show you, because we do have time, the more expressiveness of the language. So I want to say that there exists a method, so that when this method is satisfying some conditions, specifically this method is the getText method, I want you to give me back those instances. And because you remember we are in a tree, we have nodes. So I want to express these as nodes. So let's do it like that. And I'm doing the same thing here. There exists a method. When this method is being accessed, I'm expecting something. This method is the raw query. I'm going to take it from here. I can copy and paste. Let's do if we have confirmed findings and how we can visualize those. So let's do node as expression. So before I run this, just to make sure we are on the same line, the source and the sink, I'm trying to find data flow between the two, and I'm expressing those as nodes in an abstract syntax tree. So if I run this, you are going to see how powerful the language is. So on the right, we have two confirmed SQL injection findings. If I click on this arrow here, I have the paths that the first confirmed finding is occurring from. So if I click again, I can see the exact pathway and follow the variable in my code. So we can see that the first occurrence is when the username variable is being entered in the database. It's then passed into the login method, where the username and the password are checked against the database. Then it's going to the signature of the login method, and then it's being executed. And then we have another pathway of the same occurrence. I want you to see the difference between line 102 and line 116. Basically, these two lines are doing the same thing. In the first one, the developer checks if the username and the password pair is in the database and evaluates to true, as in the user authentication database, and this evaluates to false. I can't describe how many security teams I've seen in my life that they only notice the one in 102, with forgetting the one in line 116. So this means that I can execute SQL injection and hack a database, stealing credentials, credit cards, etc., because I'm not even a user there, because it's very easily missed. You want to have all the paths that something occurs on. So in here, we have another finding of SQL injection. This time is with the password variable, and you follow it around. Here, okay, I'm using a WASP security shepherd, and what I show you is easily traceable because you have a fourth pathway. But in reality, if you Google and you find how many lines the average program has and how many vulnerabilities in a line, you'll find out that the variable can pass from 12 to 15 areas. And good luck in monitoring that variable across the code base without automation or something that does it for you. So to summarize what I've shown today, we've seen CodeQL in action in two ways. We've seen the passive user, that is the person who just like turns on automation for security code scanning, and they have all these nice looking alerts that I can show you later how they look in specific examples that you want. And it shows you, oh, it occurs in here because of this and that. And then you also have the active user, the person who wants to establish some monitoring rules and writes some code for their own database internally. And it's useful because you have taint tracking, it's extensible and flexible. And the other main benefit I see is the fact that all the queries that we are writing internally and find 0 day every 3 days for the past 2.5 years consistently are something you inherit. But you also inherit the ones from the community, like enterprises around the world. I mean, 2 of them are famous for using our products, like Mercado Libre, which is the Amazon of Latin America, 125 million users, and also NASA, and hunters around the world. Like, for example, the one of Log4j in 9 December last year, we had a query ready within minutes to pick it up. And also variants of this query because we write in generic ways our queries. For those interested to start their CodeQL journey, here are 4 useful URLs. Also loads of training online, etc. And I would like to thank you for your time, for listening to this presentation. Whoever wants to have a free security, let's say, consultation for their project and keep in touch and send us stuff to review, you can see the pinned tweet in GH Security Lab. And if you have questions, I'm here today. Or feel free to reach me at jkcso. Thank you so much.
Thanks a lot, Joseph.
We're still on time, huh? That's good. Thanks so much.
We still have time. Do we have some questions in the audience?
So, because we kind of expected this, let's say you are not 100% on security monitoring today. I have some frequently asked questions that I can go over, and maybe I inspire someone to ask something more like a follow-up. So many people ask me, okay, how does this do with this problem and that problem? We try to build queries and model all the known problems we have. So for any vulnerability that has been given an ID, we have built the corresponding query to pick up that vulnerability. So we try our best. And then the follow-up question is, okay, so how do you do with false positives? So yeah, there is no product in the world to promise you like there are no false positives, especially the static analysis tools. But what we do is that we polish the queries so that they are both generic, but at the same time, they avoid false positives. And the other cool thing we do is that we give you the opportunity to say how noisy or how many false positives you want. Like, for example, some security researchers around the world want to come up with everything and filter out those that are bad examples, like false positive ones. While others want to be like, oh, I have 1 hour or 20 minutes, I only want to see the most important things. So just give me the super polished ones. So we have different levels of noise coming your way. We also use machine learning to understand how users are interacting with our queries, like, for example, good or bad, to filter those. And because many people are also asking me about Copilot, even in this conference, Copilot is an AI assistant we use. And for the examples I showed you today, the very good thing CodePilot does, especially for those who want to start their CodeQL journey, is that if I highlight some code, I know I need internet for that, so you can try this, or we can try this later together. First of all, it can explain the code for you. And I have a video that is gonna be released. I didn't say that, but like I have some video series that I try to help people around the world, developers mostly, with avoiding security vulnerabilities, because I've seen so many colleagues of mine in the security specialist world that they try to show, oh, that's how you can exploit this and that's how you can exploit that. No, I want to speak with the developer. That's how you can avoid that. So one of the things I show is that you have a new data, a new code base, you don't know many things about it, just highlight a chunk of code, and CodePilot can explain it literally line by line. So this line does this line does that, etc., etc. And this language translation thing doesn't work with CodeQL that I've shown you. It works with other languages. And last Friday, we added this thing called brushes. So in the same way you have in Photoshop, where you take like my face and you say, oh, this guy is too, I don't know, too dark here, just add some light. So you can highlight some code and you say, make it more readable. So it refactors the code still does the same thing, unit tests are still passing, but the code becomes more readable. And you also see some other like fix bug, debug, blah, blah, blah. Personally, I'm one of those people that, and GitHub also like wants me to be like that. It doesn't mean that I'm working for GitHub, I'm gonna say like things are amazing. So as a security professional, the truth is that maybe up to 2 weeks ago, if I code and CodePilot code, we have the same percentage of introducing bugs in the code. But as of the past 2 weeks, I've seen really good progress. They have implemented something called vulnerability filters. So before a suggestion is made to you, it's being checked if it's vulnerable or not. And it's actually being checked with the technology I've shown you. So I've seen massive progress. So as of now, I believe that CodePilot can write more secure code, even from me, that I'm both a developer and a security professional. However, we have still like a lot of room for improvement. And the final thing I want to say is that CodePilot with CodeQL is actually really good. So if I will do my demo with CodePilot comments, it will still be a functional demo. I will just be here, put a comment and say, give me back all instances of get text, blah, blah. And I actually expect this to come back as a suggestion. Same for here. In here, I will say not so good so far, but we are on the right pathway. So yeah, I'm one of those people that I'm not an early adopter of technology, but with this product, I was really impressed. Skepticist in the beginning, but now that I've played with it, it's really nice. What else? I have 2 minutes. Any question, by the way? Yes, please. This one.
You obviously have a lot of profiles for a lot of software problems you've already solved, right?
Yeah.
Is that list of profiles publicly available, or is that a paid service you provide, or can these profiles be improved by the community or at any platform?
So what do you mean exactly by profiles?
I mean, when you have an application, there are a lot of common problems, and all the developers are doing this same problems all over the world. And what you explained now is that you're trying to fix them globally. You try to fix them on a global level. So you're having a code base, profiles, common problems. You said that you have a catalog. Is that catalog publicly available?
Yes, so we have indeed a catalog of queries that are fixing these problems. It's actually here. So if I click on my files of the demo, and I click here, CodeQL. This drop-down menu has for every language all the known queries we have. For example, C++. Here, if I go like inside, etc., you see examples of the language. I need to play a bit more with the exact files, but I know for sure that every single query ever written is gonna be in here, like imported.
That's on GitHub.
Yeah, exactly.
Okay.
So if you install the language in the same way that I did, you are gonna have every single query on your hands. And the idea, and thanks for the question, by the way, it was a great question, is that many people nowadays, after 13 years, don't really do things from scratch. They just go and say, oh, give me this cross-site scripting query. They go in the QL file, they take the cross-site scripting, they paste it in here, and they add a bit more checks like I did here and there. With Log4j, when we released the original query that was picking the vulnerability, after that you have more variants of Log4Shell, like text4Shell, etc. Copy from here, paste in here, add a few checks, make it tailored to your code base, to your problem, to your infrastructure. So yeah, absolutely.
Okay. Thanks.
Thank you, guys.
Just on time, right? Perfect. So feel free to catch me outside for more questions, more demos where the internet connection is more reliable. If not, I will just do hotspot and I'll show you whatever you like. And again, if anybody's interested to join us for this office hours we have, I'm actually impressed by the turnover we have. Like an example, it's a known project that you maybe use in PHP called Gazol with, I don't know now, I don't know the downloads, but I can see 23,000 stars in GitHub. So they will be able to fix one vulnerability every 5 days when someone was reporting, and with us they did in 5 hours. So I'm super happy, and maybe in future I can help someone do something like this. So thanks again for your time. Happy to see you outside.